My name is Elise Munoz. I'm going into my 4th year of the genetics program here at Penn State. I focus on the role of RNA binding proteins in the transmission of the parasite between mosquitoes, its vector, and mammals, its host. When I started out at Arizona State, my first year of college, I was a political science major, and my classes were incredibly boring. And one of my friends was like, "Hey, take anatomy with me, it'll be fun." And I was like, "Okay, I like anatomy, sounds cool." So I took it, and he actually dropped the class, and I stayed with it, and as soon as the semester ended, I changed my major to biology. And I said, "Mom, I'm gonna be a scientist." And she goes, "Are you okay?" But that was really the defining moment when I got to do big science, and I could actually see the application of my work and get to play with these really huge, awesome machines. It's not just sitting there and actually doing the experiments, but there's a lot of thought that goes into it, and designing, and making sure that we're answering the correct questions. What are the big questions we'd like to answer? What are the big concerns? And then we talk about experiments that we can design to address those questions. And then it gets into the nitty-gritty, how much hydrochloric acid are you going to add, and how much vinegar do you need, right? We have 8 different professors at Penn State alone that work on every aspect of malaria, whether it's the mosquito side or it's the sickness in the humans and mammals. And having that center here, again, allows for that same interdisciplinary action. Working on a single cause, malaria, from many different aspects and many different perspectives. So I was awarded the Huck Graduate Enrichment Fund Award last year, which is $5,000 for a grad student to work on whatever they want. So in addition to giving us all these opportunities of, here, meet with everyone, discuss ideas, discuss science. Additionally, they're giving us this opportunity to pursue our own intellectual ideas and try to make that impact that way. So malaria is an incredibly worthwhile pursuit because it affects millions of people every year. Just last year, approximately 627,000 people died from malaria, and a majority of those deaths are children under 5. And 3 to 4 billion people are at risk for contracting malaria every year. And we do have some drugs that are effective, but the parasites are rapidly becoming antibiotic resistant, and we still don't have a vaccine. So really, this is what we're trying to do. This is our goal, is to hopefully eradicate malaria and save all of these people. So science really makes the world go round. There's no question. And what's really important for the future generations and other young scientists such as myself is to really, really keep that in mind, that what we're doing has a much greater impact than just us getting our PhDs. It's really about affecting change. It's about reaching out into the communities that need us, into the countries that need us, and being able to solve worldwide issues, whether that's poverty, whether that's feeding people, whether that's disease. And that is why it's so important to make sure that the next crop of scientists that are coming in are excited and passionate about their work, because honestly, it's hard. It takes a lot of time, it takes a lot of effort, but in the end, knowing that what you're doing is actually going to make a big difference helps quite a bit. When I think about life sciences, I think about understanding the world around us, understanding how we work, understanding why energy is used the way that it is, understanding why insects buzz around flowers. Very simple things that you maybe don't think about, but are an integral part of your everyday life. So the life sciences is really you and me. So what I would absolutely love to say to you right now is, we found a cure for malaria. Ultimately, that's what I'd like to be able to say. Malaria is cured.